Hello everyone. Welcome to part 3 of the Online Graduate Library Research Instruction Workshop. This video is on the mechanics of search. What I'd like to talk about today is take some of the concepts that I've already mentioned in our previous videos about how to construct a search strategy and how to think about your search strategy in concepts, put them together in search strings, and look at how you actually do that in our research databases. So I'm going to start by talking about Boolean operators, then get into phrase searching, wildcards and truncation, keywords versus subject headings in databases, how you can limit your results. I'll get into a few search examples using a couple of our research databases that you may or may not be familiar with. I'd like to mention one important thing about Omni that you should know, and then talk very briefly about how you can get further help for each particular database. Now, before we start this, I should tell you one important caveat, and that is, when you're doing your searches, do not type in questions when you're using one of our research databases. Every year I have students that come to me and will say, I was using Web of Science or ProQuest, and I got 0 results, and I couldn't figure out why. And usually, more often than not, what's been happening is they've actually been typing in a full question into the database, rather than what I've been encouraging you to do is typing in keywords, thinking about concepts. So the reason for that, we all do it. We're used to, I guess, the Googleization of the world, where we'll go to Google or another search engine, type in a question, and more often than not, we'll get an answer, in the sense that there's so much information out there. There's generally either somebody who's asked the question, or it's been already put up on maybe a discussion board, or it's in an article, or who knows. But there's a tendency then to keep on doing that. I do it myself. I do it, weekly, if not daily, usually for some kind of technology question. The thing about our databases is that they're not as sophisticated as Google. Google and other databases, like other search engines that are freely available online, have more sophisticated algorithms that they use to parse the results, to figure out if what you're searching for is what they have access to. And it's a little bit misleading because they're not necessarily intelligent, even though they have a kind of artificial intelligence in the algorithm working. Our search engines are fairly simplistic, and they run on the concept of keywords, subject headings, and so on, and a very specific kind of search language. This is why it's important to learn this as you're getting into your sophisticated searching. So let's move to the first important thing that you'll probably use more often than not, and that's Boolean operators and phrase searching. Boolean operators, there are 3 of them: and, or, and not. They come from Boolean logic, and the important thing to remember is that they link together terms in a logical way, and they tell the database, they tell the search engine to do something. So for example, if you were to take the term park and join it together with and planning, you're telling the search engine, I want you to retrieve all the results in the database that have both the term park and planning somewhere in the record. The results must contain all the terms specified. If you use or in your search string, the results may contain any of the terms that you specify. So the set of results can contain either park or wilderness, either or. And not, you are telling the search engine to subtract any results that contain the term you specify. So if you're interested in, say, national parks, provincial parks, state parks, and so on, but you're not interested in theme parks, specifically Disney, you could say any result that contains the term Disney, subtract it from the set of results. So the only thing that I would say is be careful when you use not. Be careful that you don't take out results that may have the term somewhere in the full text, but maybe not in the title or the abstract. You could always do some experiments. If you're getting a lot of results with one particular term or phrase showing up and they're not relevant at all, you might want to do an experiment where you run it with the phrase or term and then add in not and your particular phrase that you don't want to see and see how many results it actually removes. Just be careful with that one. Visually, this is what's happening. We've got the phrase cats and dogs. On the left, we see the universe of results that include cats. On the right, the universe of results that include dogs. When you combine them together using and, we get a much narrower set of results. Or will bring us both cats or dogs. Either or, some overlap, some don't. Much bigger set of results. Much more broad. Cats, but not dogs, looks a little bit, we're getting probably more than and, but less than or, and there's some that may not be included that may actually be relevant. So that's kind of what's happening visually when you use Boolean operators. With respect to phrase searching, when you use double quotes around a specific phrase to specify that you're telling the search engine that you're looking for that exact phrase. So in the example, we're looking for the phrase park planning, or park management, or park policy. It's not necessary to put double quotes around a word. If you only have one word, I see students doing that sometimes. That's not necessary to do, and it could actually lead to some results that are, or at least you may get a search string that's not really easily copied and pasted into another database. So without getting into the nitty-gritty of why I don't recommend that, all I would say is use double quotes around phrases rather than specific words. With respect to wildcards and truncation, this is another thing that people may find helpful. Putting a question mark at the end of a word replaces a single character. We call that a wildcard character. So with respect to a word like glacier, if you knew that you were only interested in the word glacier or glaciers with an S, you could put one single question mark. Many databases allow you to put up to sometimes 4, sometimes 5 question marks to replace characters. You would have to look in each individual database help file to see what conventions they use. The other operator or the other character is the truncation character, which is a star. It will retrieve variants of a particular term. So in the example, farm with a star retrieves farm, farms, farming, up to 5 characters depending on the database. Some will retrieve more than 5 at the end of the word. So this can get quite powerful, but you want to be careful that you don't say type in FA star. That would retrieve many word variants, spelling variants that you're not interested in, likely. And if you put a star in the middle of a word, you will find spelling variants like the US versus the British and Canadian spelling variants for color. Some databases also allow you to use the question mark. So again, the question mark, you could conceivably put COLO question mark R. I think the convention is the star, but you would have to check again in the help feature in each database to see what each one uses. This operator, actually both characters I believe, can't be placed at the beginning of words, unfortunately, to look for prefixes. Different databases may have different conventions, so check the help if you have any questions. The other thing that a lot of people don't really think about is the issue of keywords versus subject headings. Keyword searches are generally run in the abstracts or keyword fields of particular databases. They're not necessarily run in full text or subject headings. Now, subject headings are used in databases like Omni, ProQuest, and EBSCO, and they are headings that are added in by independent people. Sometimes we call them indexers, but they're used to actually bring together articles or records, it could be books even, that all fall under a particular subject that have been predetermined. So this gets back to the idea of the controlled vocabulary. And a good example is our Omni catalog, which uses Library of Congress subject headings, and they have a very specific heading for climate change. They call it climatic changes. So that's helpful when you're getting millions of hits and you really need to narrow down to a specific topic. And this can actually really be powerful to bring you from millions or tens of thousands of hits, maybe down to hundreds or maybe even just a few tens of results. Limiters are important when you're getting sets of results, again, you're getting a lot of results. So in several databases that are primarily peer-reviewed materials, you can limit to articles. And I'm thinking of Web of Science, Scopus, and GeoBase. And it's important to do this when you want to limit to just peer-reviewed articles and you want to take out things like conference proceedings, letters to the editor, opinion pieces, and I'll show you what I mean in our live example. And you can also limit to specific document types in ProQuest. You can limit to language. You can limit actually to gray literature, conference proceedings, or book reviews. Now, if you want to find book reviews on a specific book that you're going to be using, that's helpful. Conversely, if you want to remove things like book reviews from your results, that can also be very helpful as well.